Good morning. Welcome to Statistics and Probability. So we're now on week 6 of our lesson. In today's video lesson, we will talk about the Central Limit Theorem. So our objectives are, first, we illustrate the Central Limit Theorem, and then we define the sampling distribution of the sample mean using the Central Limit Theorem, and also solves problems involving sampling distribution of the sample mean. So let's consider a population with 15 members. No? So from this population, so we have 1 to 15 members. From the population, we will get one sample or one sample size. So what's the probability of getting 10 from the population of 15? So if your answer is 1 over 15, you are correct. And therefore, when we graph it, the shape of the probability distribution is flat or uniform and symmetric about mean. Ibig sabihin, all of the members, 15 members, have an equal chance of being chosen. That's why the probability is 1 over 15. Now, take a look at this example. From the population of 15 members, what is the probability of getting 2 samples? So when you illustrate it or when you graph it, the graph will be look like this. So notice the graph, this graph, and the graph wherein we only have a sample size of 1. Now, take a look at the same population again. What about when we get a sample of 3? So, tatlo naman sila. What have you noticed to the graph or the histogram? So, did you notice something in the shape of the histogram of the sampling distribution of the sample mean as the sample size increases? So, yung nauna, isa lang yung sample size natin. Yung pangalawa, naging 2 na. And yung pangatlo, naging 3 sample size na. So, ano yung napansin nyo sa histogram? So, when you draw a sample in the population, the values of a variable can flow different probability distribution. So, the distributions can be normal, right skewed, left skewed, or uniform. So, yung magiging uniform lang siya kapag from the population, kumukuha ka lang ng tigi-isang sample. So, as the sample size increases, kung napansin nyo, yung shape niya is normal distribution, no? Or parang normal distribution siya or normal curve. So as the sample size increases, it approaches to normal distribution. So what's the connection of central limit theorem to that? So what is the central limit theorem? So a central limit theorem or CLT states that given a large sample size, the sampling distribution of the sample mean for a variable with approximate normal distribution regardless of the variable's distribution in the population. So in other words, the theorem is saying that the sampling distribution of the mean will draw near a normal distribution as the size of the sample increases, regardless of the shape of the original population distribution. So kung napansin nyo sa pinakita nating figure kanina, mas tumataas or lumalaki yung sample size na kinukuha natin from the population, mas nag-a-approach siya sa normal distribution. So, sabi dito, as you increase the number of samples, the graph of the sample mean will move towards a normal distribution. So, ito yung itsura kanina, uniform, no? Uniform yung itsura nung out of 15 members, kumuha lang tayo ng isang sample size. So, habang lumalaki yung sample size na kinuha natin, nag-a-approach siya sa normal distribution kasi mas maliit yung sample size, hindi pa siya totally normally distributed eh. Pwedeng right skewed pa lang siya, wherein papunta sa right yung curve natin or left skewed. So, mas tumataas or mas lumalaki yung sample size natin na mas nakikita natin na yung graph ng normal distribution. So, in the central limit theorem, you may notice that the approximation is valid, no? As long as the sample size is large. But how large is large? Unfortunately, there is no clear answer to this question. Kung gaano pa or paano natin masabi na madami na yung sample size na nakuha natin. But the approximate value of the samples depends on the shape of the population from which you sample as well as on how you want to use the approximation. However, meron naman tayong mga guidelines dito na makakatulong. But how do I decide or how do you decide when the sample size is large enough? First one, so if the sample population is normal, then the sampling distribution, it follows that X bar will also be normal no matter what the sample size we choose. Next, when the sample population is approximately symmetric, you know what symmetric means, right? Therefore, the sampling distribution of X bar becomes approximately normal for relatively small values of n, where n is the sample. And also, when the sample population is skewed, it's either skewed to the left or skewed to the right, therefore, the sample size must be larger. So, kung nakaskewed daw yung sample population natin, therefore, kailangan dagdagan natin yung sample size natin with n at least. When we say at least, or at least 30, it's therefore 30 and up, no? With n at least 30 before the sampling distribution of X bar becomes approximately normal. So, kailangan muna natin ng at least 30 na sample size bago magiging approximately normal yung distribution natin. So, balikan muna natin yung variance and standard deviation of the sampling distribution of the sample mean for finite and infinite population. So, do you remember yung mga formula na pinapicture ko sa class or sa classroom? Ito yung mga yan, no? So, we have different formulas for variance and standard deviation. Depende kung finite population siya or infinite population. So, yung mga sinolve natin sa board or sa classroom, it involves infinite population. So, we have sigma squared or sigma submean squared is equal to sigma squared over n. And also, for infinite population in solving for standard deviation, we have sigma submean is equal to sigma over square root of n. So, anong difference niya kung mag-solve tayo ng finite population? So, bibigyan lang natin siya or i-multiply lang natin sa population minus sample over population minus 1. For standard deviation naman, of course, may square root na siya. I-multiply natin yung formula sa infinite population sa square root of population minus sample all over population minus 1. Ano nga ba itong population minus sample over population minus 1? Yun yung tinatawag natin na finite correction factor. So, sa pagsasolve ng finite correction factor, gagamitin natin tong formulang to. Square root of n or capital letter N minus small letter n over capital letter N minus 1, where n, capital letter N, is the population and small letter n is the sample. So let us have examples, no, on how to solve or on how to find the value of the finite population correction factor. So we're getting the population correction factor. Therefore, we will use this formula. Square root of n minus n over n minus 1. So, given na yung population, kailangan lang natin hanapin dito yung number of population and number of sample. If population is 40 and sample is 2, all you have to do is to substitute. So we have square root of 40 minus 2 all over 40 minus 1. Therefore, our answer is 0.99. So for example, number 2, what if the population is 80 and the sample is 25? So how do we get the value of the finite population correction factor? By substitution again, and the final answer, you can input it in your calculator. Or sa mga lumang calculator, pwedeng gawin nyo para hindi na kayo magkamali ng sagot or mali yung ibigay na sagot ng calc nyo. Kasi kailangan pang tama yung, yung pagkaka-input ng open and close parenthesis. So, what you do is, subtract nyo muna yung sa numerator, then subtract nyo sa denominator, and then you divide. After dividing, you get the square root of your quotient. So, para naman sa mga pwede nang magdiretso, diretso ng input sa calculator, the answer is 0.83. And for our last example, substitution, and your answer should be 0.93. So, do you have any questions regarding on how to find the value of the finite population correction factor? If none, let us proceed to evaluating learning. So here is our evaluation. I will send a Google form or Google link. You will answer only in Google form. So, ayan. You find the value of the finite population correction factor. So let us go back to the sampling distribution of the sample mean for large population. So we have properties now. The first one is the mean of the sampling distribution of the sample mean is equal to the population mean. So mu sub mean is equal to mu. Yung mean sa population, equal lang siya sa mean sa sample. Next, so the standard deviation is equal to the standard deviation of the population divided by the square root of the sample size. So that is sigma sub mean is equal to sigma over square root of n. This is used when the population is infinite. So, na-discuss na natin yan. Nabigay ko na yung formulang to. And yung mga diniscuss natin nung nakaraan, the population is infinite there. Kasi hindi naman din nabanggit yung number of population. Kaya nasabi natin na infinite siya. Next, when repeated, samples of size n are randomly selected from a finite population with n elements. Ayan. Ano natin masasabi na finite yung population natin? Kapag given yung number of population. So, the standard deviation naman, kung sa infinite population, yung formula natin for standard deviation is sigma sub mean equals sigma over square root of n, where n is the sample. So, finite population naman, yung formula naman natin sa standard deviation is sigma sub mean is equal to sigma over square root of n multiplied by the finite population correction factor, which is square root of n minus n over n minus 1, where capital letter N is the number of population and small letter n is the number of sample. So, tatandaan nyo lang, kapag yung given natin is infinite population, we will use this formula, and kapag naman finite population siya, we will use this formula. So let us find the indicated probability in the given situation. Let's have this example. So the given here are, if the probability of x bar is less than 76.5 and our population is 600, our sample is 60, our mu is 78, and sigma is 6. So let us find the probability, no, that the mean is less than, or x bar is less than 76.5. So first is we write the given. So our given are n, or the population, 600, mu equals 78, sigma, or the standard deviation, is 6, and or sample is 60, and x bar is 76.5. So yung una nating kukunin, of course, is the sigma, no? Na binigay ko na kanina yung formula. So, the formula for sigma sub x is equal to sigma over square root of n sample multiplied by square root of population minus sample all over population minus 1. So, bakit ito yung formula na gagamitin natin? So, depende kasi kung yung given natin is infinite population, finite population. So, kung yung given natin is infinite population, we will just use the formula sigma sub x is equal to sigma over square root of n. But then again, our given is finite population. Paano natin nasabi na finite population siya? Kasi given po yung number of population natin. So, lagi niyong tatandaan, kapag given yung number of population natin, we will use this formula na minultiply natin siya sa finite population correction factor. So, by substitution, we have 6 over square root of 60 multiplied, no, times square root of population minus sample all over population minus 1. And pwede niyong i-post tong video na to and you input it in your calculator. And dapat yung lalabas po natin is 0.74. So, very good kung nakuha nyo na yung 0.74. Next is we get the z-score, but we don't have the z-score here. Do you know what to do? How to get the z-score? Of course, we convert x bar to z-score. So, parang converting raw score to z-score lang siya. But then again, iba yung formula natin. Why? Kasi, yung given natin is x bar. It is not a raw score, no? And it involves finite population. Kung napapansin nyo, yung sinosolve natin dati, may formula tayo na x bar minus mu over sigma all over square root of n. That is for infinite population. But then again, we're dealing with finite population. That's why we will use this formula. So, tatlo na yung formula sa z-score, no? Yung una naman is given is raw score. Yung formula is x minus mu over sigma. Pero dito, given is finite population. That's why we will use this formula. So, x bar is 76.5 minus our mu is 78 over sigma sub x, which is ito nakuha natin dito, 0.74. And our answer is negative 2.03. Now, our next step is we graph or draw the normal curve. So, bakit po siya, sa tingin nyo, pwede ba siyang ganito? Nilagay ko na is mu, no? So, our mu is 78, always. Yung mu natin, always dito siya sa gitna. So, pwede bang ilagay na lang natin is yung z-score? Pwede naman. Pwede naman nating ilagay yung z-score na negative 1, negative 2, negative 3, 1, 2, 3, and then we locate it. Pwede rin naman pong gamitin natin yung ganito. imbes na ilagay natin is z-score, ilalagay natin is mu and x bar. So, kung napapansin nyo, hindi na siya yung 78. Then, our standard deviation is 6. So, plus or minus 6 na tayo dito, di ba? Dapat naging 84 and dito 72. But then again, those are for population, no? Raw score kasi sila. Yung given natin dito is x bar. Kaya, ganito po yung drawing niya. Para mas maganda kung z-score na lang, pwede naman yun. So, let's locate 76.5. Dito siya banda. And of course, shaded to the left. Why? Because it is less than. So, next, we get the probability. So, the probability of x bar less than 76.5 is also equal to the probability of z less than negative 2.03. Ma'am, question muna. Dapat po ba may 1 dito? Not necessarily, no? Pwedeng wala naman yung 1 na yan, pwedeng i-omit nyo na. Pero kapag kasi between yung kinukuha nyo, yung may dalawang guhit dito, dalawang z-score, mag-z sub 1 tayo, tsaka z sub 2. Pero kung naintindihan ko naman siya, na dalawa yung z-score mo, kahit wala naman subscript, okay lang, okay na yun sa akin. So, okay, getting back to getting the probability of x bar less than 76.5. So, bakit siya minus? Kasi po, hindi siya dumaan sa mean. And then, what is the probability or the area of 2.03 of the z-score 2.03? The area, so, is 0.4788. Paano natin nakuha to? Please refer to your z-table, no? You locate the area. So, 0.5 minus 0.4788 is equal to 0.0212. And that is also equivalent to how many percent? 2.12%. So, just move 2 decimal places to the right. So, therefore, kung makita nyo yung graph natin, 0.4788 kasi from negative 2.03. So, if this is the z-score negative 2.03 is this, kasi equivalent z-score of 76.5 is negative 2.03, right? So, if this is 2.03 and 75.88, bakit hindi dito yung 75.88? Or 47 rather. 47.88. So, remember yung una nating lesson, no? How do we locate z-score? So, nilolocate natin yung z-score or we find the area from the mean lagi, di ba? Kaya nga, kung shaded eto, hindi naman yun yung area ng 2.03. Ito yung area ng 2.03 from the mean, no? Kaya nag-minus tayo kasi ito lang yung kinukuhanan natin ng area. Bakit 0.5? Natin siya minus kasi one of the property of a normal distribution or normal curve is that it is symmetrical, no? And the total area is 1. Therefore, we can say that half of the normal curve is 0.5. Kaya minus natin siya sa 0.5. And therefore, we conclude that the probability that the sample you got will have an average less than 76.5 is 2.12%. So let's now have the application for central limit theorem. Example 1. Imagine that you're doing a research. So from a population of 200 with a population mean or mu equal to 75 and a standard deviation of 14, you decided to use the sample size of 35. Now, what do you think is the probability that the mean or average of your sample will be 79 or more? Of course, in a worded problem, alam nyo naman na yung una natin gagawin is always find the given. So what do you think are our given? So we have here population, which is 200. What else? So population mean is, or the mu is 75. We also have sigma equal to 14 or the standard deviation. Paano naman kapag wala yung mga symbol na to? Alam niyo naman na siguro siyang i-identify, no? Pag population, sinabing population na 200, that is capital letter N. Pag sinabing population mean, that is mu. Pag sinabing standard deviation, that is sigma. And what else? Small letter n, sample size of 35. Kapag sinabing sample size, that is small letter n. Meron pa ba? Of course, meron pa. We have 79, no? And what is 79 here? So since it involves finite, no? Finite population, kasi given na yung population natin, which is 200. Finite means countable. So, given yung population natin, therefore, our given is 79 is X bar. Next is we draw the normal curve with the given, no? Our mu is 75, so 76, 77, 78, 79, 80, and so on. Since X bar siya, kaya hindi siya yung 75, since standard deviation is 14, dapat plus and minus 14 tayo, di ba? Pero bakit 75, 76, 77? Kasi sample mean siya or X bar. So, pwede naman na unahin yung kuhanin yung z-score and then you locate the z-score from the normal curve. And pwede rin naman to, no? So, 79 is here since it is positive. And yung nakalagay kanina, 79 or more. Therefore, shaded to the left, shaded to the right, or between. So, therefore, it is shaded to the right kasi more because of the keyword more. So, we have the given, no? Sulat ulit natin or pakita ulit natin. And how to find, no? What is next? We find the sigma sub x, no? So, bakit sigma? Ito pa rin yung formula, not the sigma over square root of n lang. Bakit minultiply pa rin natin siya sa population or finite population correction factor? Dahil po, it involves finite population, given kasi yung population natin, which is 200. So, upon substitution, the answer would be 2.15. After getting this, is we get the z-score. So, bago na yung formula natin, no? Ito na yung formula natin, kamukha nung kanina. Dahil, mean yung given, at the same time, finite population tayo. So, upon substitution, the equivalent z-score of x bar is 1.86. So, huwag kayong magkakamali sa mga formula, no? Or yung gagamitin yung formula. Kasi, pag ito, ginamit nyo is yung for infinite population, mali na agad yung lilitaw na sagot natin na z-score. So, careful lang tayo. And also, pati dito. So, dapat ito yung formula gamitin natin kasi finite population yung involved. So, ilista na rin natin pati yung, ayan, ito yung given, no? Tapos, nakalagay na rin dito yung nakuha natin sigma sub x and our z-score, which is 2.15 and 1.86 respectively. So, next step is we get the probability. So, may steps naman yan, no? Una is given. After the given, we find this one, no? The sigma sub x, and then after that, we find the z-score. And then, after that, we can graph. After graphing the normal curve, we can already find the probability. Or, pwede naman hindi natin siya i-graph, kunin na agad natin yung probability. But of course, para makasigurado kung magpa-plus ba tayo or mag-minus, let's graph it. Total, madali lang naman yung pag-graph. And, okay, to find the probability of x bar greater than, no? More than kasi, more than greater than or equal to 79. Sabi kasi kanina, is 79 or more. Meaning, that is, it can be 79 or greater than 79. That's why our symbol is greater than or equal to 79. And that is also equal to P, the probability of Z greater than or equal to 1.86. Ito yung corresponding Z-score niya. So, mag-a-add ba tayo or magpa-plus? Of course, we will add. So, the corresponding Z or area of 1.86 or the corresponding area of the Z-score 1.86 is 0.4686 sa Z-table nyo. So, 4686 is from the mean lang siya up to the given Z-score, which is 1.86. But we're finding the area after that. No? So, what we'll do is we're going to subtract 0.5 to 0.4686. And the answer is 0.0314, or that is equivalent to 3.14%. Therefore, we can say that the probability of the sample you obtain will have an average of 79 or more or greater is 3.14. So I will leave example number 2 to you to solve na on your notebook. So you consider no the same population. From example number 1, yung sinagutan natin kanina, where n is equal to 200 with a mean or mu of 75 and standard deviation of 14. So this time, you decided naman to use a sample size of 40. So nag-iba na yung sample size natin, naging 40 na. Ngayon, yung tinatanong naman dito is what is the probability that your sample will have a mean between 72 and 77. So, case 3 naman to, no? Since between siya, so hindi na natin gagamitin yung 0.5, gagamitin na natin yung area, no? Ng equivalent Z-score ng 72 and equivalent Z-score ng 77. So, I will leave this to you and you answer it in your notebook. Recitations tayo sa Monday. So, the answer or your answer should be 77.95%. So, kung 77.95% yung sagot nyo, therefore, you are correct. So, you follow, no? You follow the steps in solving, no? The probability. First is the given, next is the unknown, of course, and next is the sigma sub x, and after that is you convert it into z-score. After converting it, you graph it. After graphing it, you get the probability and the conclusion. This is the conclusion. So, dapat yung sagot nyo is 77.95%. Ito yung di-discuss natin sa Monday. So, if you have questions, feel free to comment down below or message me. Now, let us apply Central Limit Theorem in worded problems. Let us now move to example number 3. According to study, the average number of hours of TV viewing per household per week in the Philippines is 50.4 hours. So the standard deviation is 11.8 hours. If a random sample of 42 households is taken, what is the probability that A, the sample average is more than 52 hours, and B, the sample average is less than 47.5 hours? So let us first solve for letter A. What if the sample average is more than 52 hours? Of course, let's identify first the given. What are the given? So we have 50.4 and 50.4 is the average. Therefore, 50.4 is our mu. Next, the standard deviation is 11.8. Therefore, our sigma is 11.8. And we also have 42, which is the sample. Small letter n, capital letter N. Of course, the answer is small letter n, because it's only sample. So, how about 52? So, therefore, 52, since 52 will be, is it X or X bar? Definitely it's X bar because we're not talking about raw scores. So the given are mu 50.4, sigma is 11.8, n or the sample is 42, and X bar is 52. So we have our given here, and to solve for or to get the probability, the first thing we need to do is we can graph or we can draw the normal curve. After that, we find the sigma or the standard deviation of sigma sub x, and after that, the z-score, we convert no, x bar to z-score so that we can get the probability. So for the normal curve, we have this. Since our mu is 50.4, 50.4 yung sa gitna. And our x bar is 52, no? So can we solve first for sigma and then z or the z-score before constructing the normal curve? Yes, no? You can also change the raw scores or the sample mean to z-scores here. So, for our sigma sub x, notice, no? Notice that our formula is sigma over square root of n only. And hindi natin siya minultiply sa finite population correction factor. Why? Because we're dealing with infinite population, no? Hindi naman given yung sample na population natin, hindi naman given yung number of population. That's why therefore we can conclude that it is an infinite population. So upon substitution, our answer would be 1.82. So after getting that, we can now convert x bar to z-score with this formula. Since we're dealing with either finite or infinite population, we will use this formula. So, upon substitution, we will get 0.88, positive 0.88. Therefore, it's located to the right. So, dito siya located. And what is the area of 0.88? The area is 0.3106. Nasa Z table nyo yan. So, you know how to locate the area of a z-score. So, the probability of x bar greater than 52 is also equal to the probability of z greater than 0.88. So, mag-add ba tayo or magsusubtract ng 0.5? So, therefore, we will subtract kasi hindi siya dumaan dito sa mean. So, 0.5 minus 0.3106, the answer is 0.1894. So, always, subtract tayo kapag hindi siya dumating sa, or dumaan sa mean. Add naman tayo kapag dumaan siya sa mean. And, 0.5 is not involved naman kapag naman in between siya. Na? So, therefore, as a conclusion, the probability that the average we obtain will be more than 52 hours is 18.94%. So, the equivalent percentage of 1894 is 18.94%. So, for letter B, how about if the sample average is less than 47.5 hours? What is the probability? So, for our given, imbes na x bar siya, or imbes na 52 yung x bar natin, magiging 47.5 hours na siya. Take note, less than. Therefore, the normal curve should be shaded to the left. So, this is our given. And to find sigma sub x, we will use again this formula. Dahil it involves infinite population. So upon substitution, our answer is 1.82. Please just input it in your calculator and verify if the answer is correct or you got the correct answer. For our, and next we convert, x bar to z score. We use again this formula because it involves finite or infinite population. Ito yung gagamitin na formula. Kapag naman sampling distribution siya, yung gagamitin nating formula is x bar minus mu over sigma all over square root of n. Kapag naman population lang yung given, given yung raw score natin, yung z-score formula natin is x minus mu over sigma. So, please know the difference, no? So, upon substitution, we will get negative 1.59. So, pwede bang ngayon pa lang natin siya i-graph, yung negative 1.59 yung nakasulat, imbes na 47.5, of course, pwede po. So, after that, we get the probability. Probability that the mean is less than, no? Less than 47.5 is also equal to the probability of z less than negative 1.59. So, subtract tayo dahil hindi siya dumating sa mean, or dumaan. Dumaan sa mean, and the corresponding area of 1.59 is 0.4441. And the difference between them is 0.0559, and that is also equivalent to, in percent, 5.59%. Therefore, we can conclude that the probability that the sample average we obtain will be less than 47.5 hours is 5.59%. So for our last example number 4, we will discuss this on Monday, no? And please try to answer it in your notebook. We will have our recitation here. Recitation na lang tayo. And, board work, na? Please try to answer this, na? To verify if nakakasunod ba kayo sa lesson. And if not, if you have questions, feel free to message me or comment down below. Okay, if there's any question, no, don't be afraid to ask. Kung may tanong ba kayo, sana pinapanood nyo to. If yes, thank you, no? And also, good for you. Siyempre, para hindi kayo ma-at loss, or kapag nasa class tayo, alam niyo na agad yung gagawin niyo. So, that's the end of week 6, no? The Central Limit Theorem. Good day and God bless.